Good day, everyone, and welcome to another of our learning journey. I'm your tutor, Joe Kelvin, and today we'll be talking on number base. I want each and every one of us to be attentive as we go through this journey. Thank you, and God bless you. Let's move straight to the notes for what we have today. A number base is is a system of counting in which certain units makes up a bundle. The bundle thus forms the next place value. The placing of the digits shows the value. Full stop. Generally, counting is done in base 10. And now base 10 is called denary or decimal. The highest digit of any number base is always one less than the base. It's always one less than the base. For example, for a number in base x, the highest digit possible must be x minus 1. Base 2 is called binary, while base 8 is known as octal numbers. Okay, so for what we read there, we found out that the number base any number base, it's one. The highest number in the number base is one less than the base itself. For example, we have base 3. The highest number in base 3 would be 2, which is 0, 1, 2, 3. I'm sorry, 0, 1, 2. In base 5, the highest number will be 4, which is 0, 1, 2, 3, 4. So in base 10, the number will count from 0 to 9. Right? Is always the highest number of that number base is always one less than the base itself. Now let's check the binary number. The binary system. So the binary or base 2 is the counting of numerals based on 2. The binary system is important due to its use in computer application. The highest number is 1. Now you see that the binary system is very important, most especially in computer application. Most of our computers, the codes and whatever are being encoded using binary. Binary plays a very important role in computer application, and that's another topic for another day. We'll go into that subsequent time. Okay, I'll prepare a topic on that and explain effectively how binary helps the computer in its application. Okay. Conversion of number base. You say conversion of number base is a process of changing one number base to another. It involves converting from base 10 to any other base, from any other base to base 10, and conversion between other bases. Now, like we said earlier, generally counting is done in base 10, right? Generally, counting is done in base 10. So, if you want to count a number, it's been done in base 10. But now we want to convert a number from base 10 to base 2 or 3 or 4 or 5, or conversion from base 10 to that number, or conversion from that any other base to base 10, or conversion between bases. Now that's what conversion of number base is all about. Okay. Now, conversion from base 10 to any other base involves successive division of the base 10 by the required base. At each step of the division, the remainders are recorded, including zeros, until the division is completed. Example, convert 124 base 10 to a number in base 8. Now they said we should convert 124 base 10 to a number in base 8. Now we said it involves successive division. Now we are dividing the number in base 10 by the required base. So it means you are dividing 124 that is in base 10 by the required base, which is base 8. We want to make 124, convert 124 to a number in base 8. That's why we're dividing it by the base 8. Right? So let's move straight to the note and see how it goes. So 124 divided by 8 is 15 remainder 4. Like we said we should record the remainders, right? So 124 divided by 8 is 15 remainder 4. 15 divided by 8 is 1 remainder 7. And 1 divided by 8 is 0 remainder 1. I'm sure we can see this. So we say, therefore, 124 base 10 is equal to 174 base 8. Now you can see that the highest number there is 7. Hmm? So that's how it works. Thank you. Let's move straight to another example. Another example, he said, express 437 base 10 in base 5. Look at the solution. 437 divided by 5 is 87, remainder 2. 87 divided by 5 is 17, remainder 2. 17 divided by 5 is 3, remainder 2. 3 divided by 5 is 0, remainder 3. So 437 base 10 is equal to 3222 base 5. Conversion from other bases to base 10. The conversion from other bases to base 10 involves basically two methods. Now, we saw how to convert from base 10 using successive division, right? How to convert from base 10 to base, um, how to convert from base 10 to any other base, right? We did it using successive division. Now, we want to convert from a number to base 10. How do we do that now? You said it involves basically two methods. First of the method is power expansion, and the second of it all is successive multiplication. I'm sure we are familiar with the power expansion, but not too familiar with that of successive multiplication. We're going to do the two um, methods and see how it goes. Now, power expansion. This is multiplying out the number base using their place values. Example, convert 110 base 2 to base 10. Now using the place value, we start with from 0, 1, 2, 3, and up to 5, because this is, now we now use the base to multiply it. So 1 times 2 raised to power 5 times 1 times 2 raised to power 4 plus 0 times 2 raised to power 3 plus 1 times 2 raised to power 2 plus 0 plus 0 times 2 raised to power 1 plus 1 times 2 raised to power 0. Now this is what we get. 2 raised to power 5 is 32. 2 raised to power 4 is 16. 2 raised to power 3 is 8. 2 raised to power 2 is 4. 2 raised to power 1 is 2. And 2 raised to power 0 is 1. So 1 times 32 is 32. 1 times 16 is 16. 0 times 8 is 0. 1 times 4 is 4. 0 times 2 is 0. And 1 times 1 is 1. So we have 53 base 10. Now, using successive multiplication as also a method of solving, also successive multiplication as a method of solving. Now, successive multiplication involves you multiplying the base by the first digit, adding it to the second digit. Your result or your answer, multiply by the base again, add it to the third digit, to the next digit again. The result, you multiply it again by the base and add it to the other digit, just like that until the multiplication is completed. Let me write it. Let me just do a quick solving so we could understand what I mean. Now, you said convert 110 base 2 to base 10 using successive multiplication. Like I said, multiply the base by the first number and add it to the second number. The result or the answer, multiplied by the base again, add it to the next number. The result, multiplied by the base again and add it to the next number. The result again, multiply it like that until the multiplication is completed. So 2 times 1, which is the first number, plus 1, the second number again, we got 3. Now, the result, which is 3, multiplied by the base, which is 2. So 2 times 3 plus the next number, which is 0, it gives us what? 6. The result, which is 6, multiplied by the base again, add it to the next number, which is 2 times 6 is 12 plus 1, which gives us 13. Now, the result, which is 13, multiplied by the base again and add it to the next number. So 2 times 13, which is 26, plus 0, which is the next number, is 26. Now 26, which is the result, multiplied by the base again and added to the last number, which is 2 times 26 is 52 plus 1 gives us 53. So 110,101 base 2 is equals to 53 base 10. So you can use either of this method. Like we see the first one, we use power expansion, we got 53, right? And this also gives us 53. So whichever method we want to use, it's fine. All right. So you see, this is how it's being done. So 134 base 5 can be converted to base 2 as 10110002. This is it.